Hello, people. Today we're going to be talking about high-performance HTAP databases with Postgres and Hyperscale Citus. I'm Claire Giordano. I work in the Postgres team at Microsoft, and I'm joined today by Marco Slot, who's an expert in distributed systems and works on the Citus open source project at Microsoft. I'm absolutely thrilled to be joined by Marco today and to be able to interview him. Now, we're going to be covering four things today. First, we're going to be talking about the Postgres open source database. We're also going to talk about the Citus open source extension to Postgres, and then we'll dive into what HTAP means, what it is, why it matters, followed by one of Marco's wonderful demos. And then we'll be having conversation and interview questions throughout, and for those of you who are attending live, we'll have some Q&A at the end. Now, before I attend a talk, I always want to know up front, what am I going to take away? What am I going to learn from this talk? So I'm just going to tell you right now, the first thing you'll walk away with is an understanding of what an HTAP database is. And then secondly, we'll dive into why Hyperscale Citus is such a good fit for HTAP. But I should probably start with introductions. So this is a picture of me, Claire Giordano. I'm taken at FOSDEM earlier in 2020. It was right after I gave the Postgres talk in the dev room. It was the kickoff talk, the first one of the day. And I'm posing here with Slonic, who's the mascot of the Postgres open source community. Now, I've been working on Postgres for over 3 years now, and prior to that, I started my career as a software engineer working on developer tools, and I also spent many years as a senior engineering manager in the operating systems group at Sun Microsystems, where my team built a lot of resource management capabilities and super useful things like Solaris zones. But I'm here today to interview Marco Slot. Marco is a principal engineer in the Postgres team at Microsoft, and I kind of want to pause on that and shine a light on the fact that there is a Postgres team at Microsoft. We've been investing quite a bit in Postgres in recent years. In 2017, we launched our managed database service for Postgres running on Azure. And then in early 2019, we acquired a Postgres company called Citus Data. So I'm showing a screen snapshot from Bing of one of the many, many articles written about that acquisition. And that's actually how Marco and I both landed at Microsoft. And then more recently, we've hired a number of Postgres committers to join our team. This is a screen snapshot of a blog post that features 3 of the Postgres committers that we've hired. Postgres committers are people who have contributed a lot to the Postgres database and who own key parts of the source base. And in the case of Andres and Jeff and David and Thomas, they're continuing to contribute and roll up their sleeves and are very active in the community. But we're here to talk about and talk with Marco. So this is a picture of him with longish short of hair taken during the COVID quarantine days when it's impossible to get a haircut. He's based in the Netherlands, and he's the lead of the Citus open source project. I actually filmed this video. It's a snippet of a video when I was visiting the team a few months ago, and that's Marco in the orange sweater. Now, the Citus open source team, they're distributed in many countries. Obviously, the Netherlands, Turkey, France, Canada, the United States. So we've got a worldwide presence and lots of different people who speak different languages from different places. And it's a wonderful collaboration. So Marco started his career as a software engineer when he got his master's degree at VU University Amsterdam in distributed systems. And from there, he went on to Trinity College Dublin, which is, of course, known for its serious scholarship and also some very beautiful old buildings like this one. At Trinity College, Marco got his PhD in self-driving cars. Now, that might sound like it's a far cry from distributed systems, but in fact, his PhD had a distributed systems angle to it. This is a screenshot of his PhD thesis with which is a simulation of a place in Dublin called Merrion Square. And he had to figure out how to have all these different self-driving cars cooperate with each other to figure out things like, well, which one gets to go first at the intersection. Now, when I was interviewing at Citus a couple of years ago, it's kind of ironic. I had to create a piece of content that would be useful to developers to help them understand what Citus does for Postgres. So this is the content I created as part of my job application. It was called, "Are you ready to scale out Postgres but don't have a PhD in distributed systems?" And I guess when I wrote it, I wasn't really thinking about Marco as my target demographic because he obviously does have a PhD in distributed systems. Now at Citus, Marco has worked on almost every single part of the Citus extension to Postgres. And here I'm showing a screenshot of all of his commits. It's from our GitHub repo. All of his commits since early 2016 when we first open sourced and unforked Citus. Now we're also here to talk about Postgres, which, as you know, is open source. The tagline for it is the world's most advanced open source relational database. And I actually ripped this headline and this image straight from the PostgreSQL.org community website. What you may not know is that Postgres is more popular than ever. Obviously, it has 30 years of data integrity and hardening and all sorts of robustness built into it from all the hard work that people have put into it. What you might not know is that it was voted DBMS of the Year 2 years in a row by DB Engines, which ranks all the databases, and was also voted one of the most loved and most wanted databases in the 2019 Stack Overflow Developer Survey. Now, one of the other reasons that Postgres is super popular is because of the PostGIS extension. PostGIS is also open source, and it enables Postgres to be used for some really powerful geospatial use cases. Now, I actually believe that extensions have a lot to do with why Postgres is popular and also why there's so much innovation in the ecosystem surrounding Postgres. A few years ago, I was at PGConf.eu in Lisbon, and I sat across the table from Paul Ramsey, who's actually the chair of the PostGIS steering committee, and I asked him how he felt about extensions and whether they were integral to all of the innovation that we're seeing in the space. And he said something that struck me so much that I ripped off a piece of the tablecloth. That was one of those paper tablecloths, and I wrote it down. And he said, "We are still dining out on the radical design decision by Michael Stonebreaker in the original design of Postgres to have runtime extensions." And that I wrote it down, I stuck it in my purse, I went back to my hotel room that night, and I went to go look it up and find that initial design document. And so this is a screenshot of just the first page. This was published back in 1986. And sure enough, number 2 on the list of design goals, I've now put a box around it, says provide user extendability for data types, operators, and access methods. And I feel like this just shines a light on the importance of having really good design goals in any software project. But this has been, I think, instrumental to the growth and the usage of Postgres around the world. And speaking of extensions, I want to quickly introduce Citus, the extension of Postgres that Marco works on. So I mentioned earlier that it's open source. Here's a screenshot of our Git repo. And on some of the slides, by the way, I've put short URLs, aka.ms URLs on the slide to try to make it easy for all of you to look things up. Now, Citus is not a fork. And what that means is that it's very easy for us to keep the Citus extension up to date and current with the most recent releases of Postgres. And what makes Citus really special and unique and powerful is that it transforms Postgres into a distributed database. And what that means is that Citus distributes both your data and your queries across multiple machines. And that gives your application parallelism, right? The ability to do all that computation across multiple machines. And it gives you all the CPU cores and memory and disk of a distributed database cluster. Now, from the time that we were acquired by Microsoft in early 2019, the team hunkered down and was really focused on integrating Citus into Microsoft Azure. And in November of 2019, we announced the general availability of Hyperscale Citus on Azure Database for Postgres. So what that means is Hyperscale Citus is now available as a deployment option that you get to choose when you're provisioning your Azure Database for Postgres server. You can either provision a single server or you can provision a Hyperscale Citus server group. So after that long drum roll, I am happy to introduce you to Marco Slot. Marco, welcome.
Thank you, Claire. Excited to be here.
And now I want to dive into the questions. Are you ready?
Yeah, sure. Bring it.
All right. The first question is, why do you think Postgres is so popular among developers?
Well, I think one of the main reasons is that Postgres is there for you at every stage of your application lifecycle. And it's very easy to get started with Postgres. You can download it and install it on your laptop. It works on Linux, on Mac, on Windows, on FreeBSD. And out of the box, it comes with good tools. For example, the pSQL command line tool. And that makes it easy to experiment and create some tables, load some data, maybe roll back. And it's also very mature software. So you can take your experiment into production and be very confident that Postgres will do the right thing and keep your data safe. And then there are managed services like Azure Database for Postgres, which is built by my teammates, which help you run Postgres and take care of your backups and monitoring in HA. So that makes it very easy to operate as well. And then if the day comes when your application becomes very popular, Postgres also gives you the ability to scale, and it has very advanced tools like partitioning and partial indexes, and ultimately you can scale out using Hyperscale Citus. So it's a bit like having a boat on which you can learn how to sail, but you can also take a crew around the world. And that's quite special. And because developers love it so much, they create great client libraries and tools and extensions, and they contribute to Postgres. And that makes the whole ecosystem better. And that makes it also easier to get started for other developers or take your app into production. And that draws in more developers who make more great tools. And so that's really the power of open source, that it's this self-reinforcing ecosystem.
Let me ask you about Citus now. I talked earlier about how Citus scales out Postgres horizontally, but I didn't explain anything about how it works. Can you tell us how the Citus extension works?
Sure. So a Citus cluster consists of multiple PostgreSQL servers, one of which is called the coordinator node, and the rest are called the worker nodes. And your application connects to the coordinator node, and to the application it just appears as a single server. But the data is actually going to be stored on the worker nodes, and as the name suggests, they do most of the work. Now, the coordinator just acts as a regular Postgres server until you call a magic function called create distributed table. And what that does is it partitions your table along a distribution column into what we call shards, which are actually just regular Postgres tables on the worker nodes. And from the moment you call create distributed table, if you run a query on that table, the Citus query planner will take over and answer your query by sending multiple queries to the worker nodes in parallel and then combining the results on the coordinator. And so that allows you to parallelize your queries across all the cores in the whole cluster, but it also allows you to keep using all of the flexibility and features of Postgres. You can use JSONB, you can use joins, functions, constraints, etc. Citus is also very capable of handling transactions, and it can do so with very high throughput if the commands in the transaction specify the distribution column. For example, an update has a where clause which filters on the distribution column. In that case, Citus knows that this update only needs to go to one specific worker node. And in that case, every worker node will be working on a different subset of your transactions at the same time. So by parallelizing queries, Citus can handle analytical workloads, and by routing commands, Citus can handle transactional workloads on the same database. And that's what makes Citus such a great fit for HTAP workloads.
Okay, so that's a perfect segue into my next question. I don't think everybody's familiar with the acronym HTAP. So what does HTAP stand for, and why are we even talking about HTAP databases today?
So HTAP stands for Hybrid Transactional Analytical Processing. And it basically stands in contrast to the traditional notions of OLTP, online transactional processing, and OLAP, online analytical processing. And most applications actually have a mixture of transactions and analytics, but databases are typically only good at handling one of those, or can only do both if you have a relatively small data set. And if you have a very large data set, what you might end up doing is deploying different databases and for transactions and analytics and then gluing them together. Maybe you have to take your data from your transactional store into a separate storage system, apply some transformation, write that to your OLAP store. Maybe there's some cache to serve a dashboard. So your operational cost is relatively high because you have to know and operate all these different components. And then you have to write a lot of glue code. And there's probably a lot of lag between an event or a transaction happening and it actually showing up in the analytics on the other end. And also it makes data management harder because you have data stored in lots of different places, so you can't just run an update or a delete across these systems. The promise of HTAP is that there is finally a database that can do transactions and analytics at scale. And that means you only have to know and operate a single HTAP platform. And because you can do transactions and analytics in the same system, you can often do things in a much smarter and more efficient way. And I'll try to show you that in my demo today.
All right, so speaking of the demo, can you tell us a little bit about what you'll be demoing today? I want to understand the anatomy of the demo before you start.
Sure. I will show a demo of a database for an order processing system for warehouses. And it's all going to be running on Azure. And the application is simulated by an awesome tool called HammerDB, which is an open source database benchmarking tool, which supports several different databases and several different workloads. And one of the workloads it supports, it's called TPCC. And it's a standard benchmark for measuring transaction performance. And that models an order processing system for warehouses. And so we're going to do a side-by-side comparison of a hyperscale Citus cluster and a single Postgres server, running transactions using HammerDB and running analytical queries. And then finally, I will show you how you can use rollup tables to do millisecond analytics in the same database.
Okay, I'm excited. I think it's time to jump in.
So let's switch to my screen. Cool. So I'm going to do an HTAP demo. An HTAP might sound like something very new, but almost all applications have transactional and analytical components. I mean, who runs an online shop which processes millions of orders per day, but never asks how much money they're making? And a relational database like Postgres is quite suitable for handling both transactions and analytics. But when your database becomes very large, a single node database might struggle to answer the analytical queries and you might end up deploying a separate system just for analytics. But with a Citus cluster, you can keep up with very large transaction volumes and also do very fast analytics on the same database. Now, the easiest way to create a Citus cluster is to go to the Azure portal to provision an Azure database for PostgreSQL database. And when you create a new database, you can choose the Hyperscale Citus deployment option. And when you click create, that will take you through a form where you can pick things like the region and the number of worker nodes. But in this case, I already created a cluster. So here you see some details about my cluster. And on the right, you can see this is a cluster with 10 worker nodes with 16 cores each. So that's 160 cores in total. And if I ever need more capacity than that, I can go to the configure tab on the left and use the slider to pick my new number of worker nodes. I'm going to use the command line for this demo because, well, I love to use command line, and it also gives me the opportunity to do a side-by-side comparison of my 10-node Hyperscale Citus cluster, which will be on the left, and a single Postgres server with 16 cores that will be on the right. So the Hyperscale Citus cluster is 10 times bigger than the Postgres server. So let's have a look at what's in these databases. And I can see that HammerDB generated a table of customer data and orders and the order line table, which contains an item for a record for every item ever ordered. And we'll do some analytical queries on this table later. Now on Citus on the left, you can see that this adds up to a total of over 300 gigabytes. And on the right, on Postgres, we have around 200 gigabytes. The reason there's more data in Citus right now is because both these databases are processing transactions, and Citus does so at a higher rate, so the database is growing faster. Now let's have a look at what's going on in these databases by querying pgstat activity, which shows me all the connections to Postgres and what query they are running. And you can see that both databases are handling hundreds of concurrent stored procedure calls. Now, stored procedure is basically a little program containing queries and data modification statements that's stored in the database and typically runs as one transaction. And we can even see the source code of the program. For example, let's look at the payment procedure and open it up. And you can see that it has selects and some updates and an if statement with some selects and then some more updates. And finally an insert. And so this all runs as one transaction. And we're doing the same thing on Postgres and on Hyperscale Citus. But because this transaction only deals with a single warehouse, on Citus we can route it to the different worker nodes and speed up the transaction throughput. So in the background, I'm tracking the number of transactions that each of these systems is running per minute. And I can see that using the transaction throughput view that I created. And if I look to the right to the Postgres server, I can see that in the last 10 minutes, it did between 40 and 50,000 transactions per minute, which is quite decent because I could run a pretty large online shop with that. But on the left, the Hyperscale Citus cluster was able to run around 900,000 transactions per minute. So that's around 20 times faster. And the reason it's 20 times faster and not just 10 times faster, even though it has 10 times more CPU and 10 times more IOPS, is that it also has 10 times more memory and therefore can fit all the data in memory. And if I want my data to continue to fit in memory, I could even keep adding more worker nodes over time. So this is also a big difference between a sharded architecture and an architecture that uses read replicas, because in read replicas, you typically have the same subset of the data in memory on every node, whereas in a sharded architecture, we divide it across the nodes, and all of the nodes can also handle writes. So that makes it quite powerful. So far we've looked at the T in HTAP. Now let's look at the A, the analytics. So here I'm running a query that calculates the total amount of sales by state and gives me the top 10. And the data here is completely made up, but in the bottom left, you can see that Citus finished the query in around 10 seconds. On the right, Postgres is still working on it, and unfortunately, we will not see it finished during this demo or even during this talk. I know this because I actually already ran the query on the Postgres server before I started the demo, so I'll switch to a different screen. And here on the right, you can see that it took 53 minutes to complete the query on the Postgres server. So the Hyperscale Citus cluster was over 300 times faster at answering this analytical query by parallelizing across all the cores in my cluster. And if I do a select count star from order line, I can see that this query was actually a join on over 700 million rows, as I can see in the bottom left corner. So this shows that Hyperscale Citus can do these analytical queries on top of an transactional workload in just a few seconds. But what if I need it to be even faster? So we'll leave the Postgres server behind and focus on the Hyperscale Citus cluster. What we often recommend to Hyperscale Citus customers who need very fast analytics is to create rollup tables. And a rollup contains pre-aggregated data for some set of dimensions. For example, here I have a rollup called total sales rollup, and for every warehouse, sales district, and state, it stores the total sales amount so far. Now we'll need to update the rollup as new transactions are happening, and for that I created another stored procedure. My stored procedure contains one command, an insert select command, which is a command that inserts the result of a select query into a table. In this case, it inserts into my rollup table and it finds all the unprocessed orders that have not been added to the rollup yet. And for every combination of warehouse, sales district, and state, it calculates the sum of the sales and inserts that. Or if a record already exists, it does an update by adding to the total sales amount. On a single Postgres server, this command would not be able to keep up with the large transaction volumes because it can only use a single core. But the Hyperscale Citus cluster is always able to keep up by parallelizing this command across all the cores in the cluster. So Hyperscale Citus can not just parallelize select commands, but actually any type of Postgres command. And because we're only querying for the unprocessed orders and the worker nodes can use indexes to find those orders efficiently, we can combine the power of parallelism with indexes in one big distributed transaction that takes all the new data and updates my rollup table. Now let's run the procedure to catch up with all the latest transactions, and you can see this only takes around 2 seconds. Now we can query the rollup table, and because this table is relatively small and has indexes, it only takes around 20 milliseconds to get the same query result that I got with my analytical query before, except it's a bit more up to date now. So I went from a query taking 53 minutes on a Postgres server to using parallelism in Hyperscale Citus to make it 10 seconds. And then by doing a parallel distributed transaction inside my cluster, I was able to bring it down to 20 milliseconds. So what we've seen is that Hyperscale Citus is able to handle and scale transactional workloads really well because it's built on Postgres and can just route the transactions to different Postgres servers. And by parallelizing queries on top of many Postgres servers, it's also able to handle analytical queries at the same time on very large data sets. And then by combining transactions with parallel queries, we can actually process the data inside the database at a high rate to make analytics even faster. And this is really the power of HTAP. Normally, I might have to deploy several systems to get all these different functionalities to be that fast, but with Hyperscale Citus, I have a database that can scale and will handle almost anything.
All right, so I have to ask you, will all applications see the kind of impressive performance increases that you just showed us?
Well, there's of course a question of, what are we comparing? And it shouldn't come as a surprise that a 10-node Citus cluster is faster than a single Postgres server. But it might be a little surprising that we could make it 150,000 times faster in the end. And actually, you might still be able to get that if you used an architecture where you took the data out and put it through in an analytics database and had some cache to make the rollup query fast. But I didn't have to do that. All I had to do was run a few SQL queries, and they run in parallel and do all the work for me. And the technique of creating rollup tables is really very powerful for scaling real-time analytics. And for the transaction throughput, we used a technique called stored procedure delegation. And to make these techniques work well, one thing that's really important is to find a good distribution column. Ideally, it's one, if you have multiple big tables, that is common to all tables, such that if you have a transaction, it can touch on different tables, but on the same distribution column value. Or if you do a join between two tables, ideally that join is on the distribution column value. And very often it's actually not that hard to find this column. For example, it could be your customer ID or your device ID. And if you can find that column, then you can scale your application in the same way.
Okay, and at the end of the demo, Marco, you referred to Citus as an almost anything database. What did you mean by that?
Well, remember that Citus is an extension to Postgres. It doesn't take any functionality away. And as a relational extensible database, Postgres is capable of so many things already on a single server There are so many different applications that run on Postgres. But the one thing it cannot do well is scale to meet the needs of very data-intensive applications. But now with the distributed tables that you create using Citus, it can do that too. So Hyperscale Citus transforms Postgres into a database that can really do almost anything.
All right. So let's say that we have some developers watching this talk and they want to get started figuring out whether Hyperscale Citus is a good fit for their application. What do you recommend? What are the best ways to roll up your sleeves and try this out?
Well, it's easy to download the open source packages from our website and set it up on your local Postgres server on your laptop. And once you've done that, I recommend going through some of the tutorials on our documentation. For example, we have a tutorial on how to distribute a software as a service, a multi-tenant application using Citus, and another one on how to build a real-time analytics dashboard using Citus. So I would recommend going through those tutorials and learning about the distribution column, and then take it from there.
Okay, thank you. And do you have a favorite blog post? I know that many of the Citus engineers write blogs. You write blogs, I do too. And some of them have actually been quite popular. So among all those many choices, do you have a favorite?
Yeah, I think my favorite is one you wrote about one of the biggest Citus clusters out there. And, most people have much smaller clusters with, 4 or 5 nodes. But at Microsoft, the Windows team has a cluster that collects and analyzes all the telemetry data coming in from Windows machines. And there's over 1.5 petabytes of data in this cluster. And what's also really cool is that if you look at his architecture, it really speaks to this HTAP model where it pretty much is just Postgres with Citus and an analytics dashboard. And within the cluster, he does the team does transformations of the data. And they do updates of older data, and then all these analytical queries on top of that. And the engineer who built it, Min Wei, he tried all sorts of different solutions to building this system, but eventually he realized that Citus was the only way to do it, and he gave us this great quote that distributed PostgreSQL is a game changer, and I have to agree.
Today, I was hoping you might mention the Citus newsletter.
Yeah, I mean the Citus newsletter is our monthly newsletter, which contains content from our blog, but also other Postgres content. And things about Azure or things happening in the community. So I definitely recommend signing up for our newsletter. It has some pretty good stuff every month.
Awesome. And I completely agree with you. So what should we take away from your HTAP demo? We made a promise in the beginning that there would be 2 takeaways.
Yeah, so one of the takeaways was, what is an HTAP database? So, well, if you think of a dictionary definition of an HTAP database, I think we can say it's a database that can handle both transactions and analytics at scale. So, which means that you only need to manage a single platform to power many different aspects of your application. And nowadays, this is not just a pipe dream. Hyperscale Citus is very capable of running these large-scale HTAP workloads by distributing Postgres and parallelizing your queries and routing your transactions across the cluster while still keeping all the powerful functionality and features and rich ecosystem of Postgres.
Thank you so much, Marco. And for those of you who are watching this video online, we hope it's been useful, and want to say thank you in as many different languages as we can. I'm also going to put our Twitter handles up on screen, both Marco's and mine, as well as the Citus Data and the Azure DB Postgres Twitter handles if you want to follow up with us that way. And for those of you who are here for the online Q&A, let's get started.